All right, so I told you I'd look at exercise 1.18. That's the thing with z to the fifth minus 1 is equal to z minus 1 z squared plus 2z cosine pi over 5 plus 1 times z squared minus 2z cosine 2 pi over 5 plus 1. And they say show that's true and then get closed formulas for cosine of pi over 5 and cosine of 2 pi over 5. And yeah, I'm still kind of at a loss as to what the authors are expecting. So here's, I mentioned this in class, and here's what I can do, or would do, or have done, or something like that. I know I can factor this thing into z to the fourth plus z cubed plus z squared plus z plus 1. So that I know. And then I can work with some different values of z to kind of play around with this. So for instance, I think in class I'd mentioned the e to the I pi over 5 and e to the I 2 pi over 5. So consider if we go first with z equal e to the I 2 pi over 5. Well, so what I know then, of course, is z to the fifth is equal to 1 in that case, because it would be rules of exponents, and so I'd get e to the I 2 pi. And so I get 0 if I put it into the left-hand side. So you see I would have 0 equals. And here I would have the e to the I 2 pi over 5 minus 1. Well, the main thing here is that's not equal to 0. And so what I know is this other thing that would be e to the I 8 pi over 5 plus e to the I 6 pi over 5 plus e to the I 4 pi over 5 plus e to the I 2 pi over 5 plus 1. I know that then has to be equal to 0, that part, because one of the two has to be 0, and I know that's not 0. And so then further, as I look at these numbers, so some things to notice here. If we got up to e to the I 10 pi over 5, that would be back to 1. And of course, that would be z to the fifth and all that. But let's look at these two things here. And if I think of this geometrically, right, there's e to the I 2 pi over 5. But down here, and if this is theta, then this is minus theta. This is e to the I 8 pi over 5. Because, so theta here is 2 pi over 5, and theta here is minus 2 pi over 5. And so that's the reflection over the x-axis here, or the real axis, is the definition of a conjugate. So in this case, what I have is that that z to the fourth is actually just z conjugate. So I have z conjugate instead of z to the fourth. Now, if you look at these two, you get the same sort of thing. So they are reflections across the x-axis. And so, but the e to the I 4 pi over 5 is z squared, right? I'm letting z be this e to the I 2 pi over 5. So that's z squared. And so I have, instead of z to the third, I have z bar squared, or z conjugate squared, and then plus z squared, and then plus z plus 1, and that all equals 0. And now you see what that does for me is, if I kind of rearrange here, I have z bar plus z, and then plus z bar squared plus z squared. And if I move the 1 over, I get a negative 1. Okay. Since I can move the conjugate in or out of the square, what I have here is, this is just the definition of, if I put 2 there and a 2 there, that's, this is the real part of z. So what I have here is 2 times the real part of z plus 2 times the real part of z squared. Okay. And that is equal to negative 1. Now notice, that the real part of z is kind of what we want to get at, because, well, let me write it here, right? We have z is equal to e to the I 2 pi over 5. And so that means the real part of z is the cosine of 2 pi over 5. So you see there, we're coming up with that cosine of 2 pi over 5. And now the z squared, that's a little bit tougher. But again, if I look at the geometry of everything here, then I can kind of play with that and get something different. So if you, let's see, so let me draw this. So there is e to the I 4 pi over 5. Okay, because I'm just going an angle of an argument there of 4 pi over 5, so not quite pi. But now, look at some symmetry here, is that if I came here at pi over 5, okay, so I have that. And so what we see here is that the real part of e to the I 4 pi over 5 is equal to minus the real part. I'm running out of room there. Equals minus the real part of e to the negative I pi over 5. Okay. And And so is, oh wait, I said is, yes, yeah, okay. And but that's also then equal to minus the real part of e to the I pi over 5, because they're conjugates of each other, plus I can just look at the, I should put a minus there and then pi over 5 there. And so this thing here I can rewrite so that I have 2 times the real part of z minus, and I'll write it this way for the moment, 2 times the real part. It's of e to the I pi over 5. Well, so that's actually the square root of z, or z to the 1/2. We'll write it that way for the moment. And that equals 1, negative 1, sorry. Okay, divide everything by 2 and put in our real parts, and we get that the cosine of 2 pi over 5 minus cosine of pi over 5, since that's the real part of that, is equal to negative 1/2. All right, so I can use z equal e to the I 2 pi over 5 and this factorization to come up with this identity. Okay, so what we'll do is we'll stop there, and then I'll look at something similar with another value. And in particular, letting z equal e to the I pi over 5. But so we'll stop this video here and then start a new one.